Hi guys! Happy weekend, or roughly the weekend to you, depending on when you decide to watch this video. What we're going to do today is we're going to do more math on good old Microsoft Paint. We're going to review how to graph some trig functions, and then we're going to move our way into what happens with our b and c terms inside our trig functions. So a quick review question first, and I'm going to do a little bit more to lay out the problem that I didn't do necessarily last time, just to add to it. I'm doing this strictly on Paint. Is let's say we have the equation y equals 3 times the sine of x. I'm going to start with something very basic. So hopefully you remember from last time we talked about how all of our trig functions, and I'm using sine here, but we can switch out the sine to a cosine or a tangent, whatever we need. All of them are going to be, oops, I already missed something, in this form, bx minus c plus d, where d is the same thing as k, but c is not the same thing as h, not when there's a b there anyway. Alright, so our a here, instead of calling it just the vertical stretch now, we're calling it the amplitude. So I can see here that I do not have a b, c, or d term. Oh, and I'm going to go ahead and actually use a positive on that. C, but all I have here is my amplitude equals 3. So that means it has a vertical stretch of 3. So on this, I know that you guys use calculators, and I have you use calculators a lot, but I want to show you if I have to graph a trig function completely by hand what that would look like, because again, your next time you see trig in a college class, they will not be letting you use calculators according to the math departments I'm aware of. And the ones that I know the best are University of Utah, as well as Slick. So just be ready. So when I'm graphing one by hand, I revert to what the normal period is. I hope you remember from before, the normal period of a sine function was 2 pi. And I personally like to graph 2 full periods, mostly because that's what most of the textbooks ask you for. So I just do that by coming over here and going to the negative 2 pi. So I'm going to have my function start in the middle on the y-axis, and I'm going to fill in some points. Now, for each period, what I do next is I divide it into 4 equal parts, because I mentioned last time how your important values, the ones that you use to anchor your points down, are just your zeros and your minimums and maximums. And they alternate, and it turns out in a period you can expect to see 4 movements, we'll say. 5 if you count what happens on the x-axis, or on the y-axis, sorry. Okay, so I think the best place to always start is at the origin. The y value when we have a sine of 0, and again, I do hope that you would use your unit circle to verify this, but on the unit circle, remember I talked about how the positive x-axis is always going to be the place of 0 degrees and 0 radians. It has a height of 0, and your y value on the unit circle was equal to 0. So, or rather, this had was at the point 1, 0. This 0 is going to be what the sine of 0 equals. So, your sine function starts at the origin. And if you remember from last time, you always stay between 1 and negative 1. And it's just because, as you go around the circle, the maximum y value is 1, and the minimum y value is negative 1. As you go around the unit circle, your y value never goes past those points. So, when we get up here to that pi over 2, we were at our maximum. when we came here to pi, our y value at that point was at 0 once again. And as we kept going around the unit circle, at 3 pi over 2, we were at our minimum. And then 2 pi was at the same place as 0 radians. We were back to here. Now, only difference with the graph that we're dealing with, because right now this is a y equals the sine of x, is the fact that we have an amplitude of 3. So that means we're going to go up to a positive 3 and a negative 3. So here's my simple little trick for you. If we're not shifting the graph at all, and in this case we're not, all I do, and I know this is going to feel like cheating, kind of is. This only works if you're not shifting the graph. Is I just relabel those. It's really that easy. Okay, and we want to come do our second period, so we have a negative pi over 2, negative pi, negative 3 pi over 2, and I can see the pattern here that's happening with my graph. I know I'm going to need to continue that pattern on the other side. Alright, beautiful, isn't it? So if we go to desmos.com and graph that function, I'm going to set this so that it goes from negative 2 pi to 2 pi. And my y's, I need it to go at least to 3. I like to go a little bit higher. And your step here, if I set it to go step by, right now I'm having it step by pi over 2, because each x value spacing was by pi over 2. I type in pi divided by 2, and we can compare what's happening between our two graphs here. I see both of them started in the center. At pi over 2, it goes up to 3. At pi, we're back at 0. At 3 pi over 2, it's down to the minimum. And at 2 pi, we're right back on the x-axis. Okay, so that's just a quick refresher on what happens with the amplitude. I could add and subtract things here. I'm not going to do that in today's lesson. We're going to spend a couple days on this and try to work you into the most complicated problems. But what I want to do instead is I want to focus on what happens when we have a b value or a c value. And of course I mean a b value or a c value in terms of this right here. Okay, so going to delete these things. Close. Okay, good enough. Alright, so let's try something that looks like, let's change our color there. Let's do y equals sine of, yeah, let's do a 3 here. 3x. So we moved the 3. The last time I had it out in front, but now that it's here, it's not an amplitude anymore. What we have here is we have a new period. Because we have a 3 here, it has a new period. Now, unfortunately, the way it works mathematically, 3 is not the new period. You're going to have to do some solving. So, what we have here is, you know, your well, can't spell. Okay, your normal period we talked about last time for a sine function is 2 pi. What you're going to do is you're going to set your normal period equal to that bx term. Now, if we had a c here, it would still just be the bx term. And you're going to solve for x to get the new period. So we have 3x equals 2 pi, divide by 3, divide by 3. X equals 2 pi divided by 3 is the new period. And once you know your new period, it makes it easier to jump right into the graph. It's going to take a minute. I know there's probably a better way to do this, and you guys probably know what it is. Just going to give myself some more space here. That's what happens when I use Microsoft Paint instead of a smart software, like Smartboard. Okay, so again, we're graphing y equals the sine of 3x. Here's your hint. Again, I'm going to have you graph 2 periods because that's what I see in a lot of textbooks. If I make my dash out here, I want it to match the new period. This is going to be 2 pi over 3. And just like before, what I'm going to do is I'm going to divide it into 4 sections so that I can alternate between the zeros, the minimums, and the maximums. And just mathematically think about what this is going to be. If I take half of 2/3, 2 pi over 3 divided by 2. I have a fraction inside a fraction. Remember the rule? You take me, the top one. Remember I told you about how I like to flip my sister upside down? Me is the first one, I do not get flipped. The bottom one though, my sister, the second one, gets flipped. And then, again, one of the things I noticed that your middle school teachers and maybe elementary school teachers didn't practice with, it seems, at the feeder schools for Ames anyways, is this idea of cross-canceling. That if you see that you have the same number on top and bottom in a multiplication problem, that you can go ahead and cancel. So out of this I get pi over 3. And just because I think we should practice fractions, let's go ahead and find these other 2 as well. If I take pi over 3, and I'm going to have to divide it by 2 to find this one here. I stay with my same orientation, but the sister gets flipped upside down, the second one. In this case, there's no cross-canceling that can happen. We just multiply straight across, and we get pi over 6. I do recommend you practice with your fractions because they are going to keep coming back in your higher math classes. I think that's one of the things that people struggle with when they go into their higher math classes is they stop practicing fractions, and it's because the schools have you stop practicing, but then all of a sudden all the college textbooks depend on fractions. Okay, and one more. I now want to find this last missing spot here. I know it's halfway between pi over 3 and 2 pi over 3. I could use the law of averages to find this. I'm going to use instead fraction addition because I know that this number here would have to be pi over 3 plus another pi over 6. And I just want to remind you that the rule is they have to have the same denominator to add your fractions together. I know 6 is going to be a common denominator, but you can't just change the bottom here to 6. You have to multiply by a special form of the number 1. And if you have the same thing on top as you have on bottom, that by definition is 1. So what I have here is I have 2 pi over 6 plus pi over 6. And I see that that's going to equal 3 pi over 6. And that will simplify, I hope you see, because we've got a 3 on top, 3 on bottom. That will simplify to pi over 2. So very conveniently, all stuff on the unit circle. Won't always work out like that, but in this case it did. And to get my second period, the easiest thing to do is to mirror image this on the other side. Okay, now I have a sine function once again. Because my a value out here is not showing, it means it must be 1. So that means my amplitude here is going to go from 1 to -1. And because I don't have any horizontal shifts of any variety, I know I'm going to start at x equals 0. And then just the simple reality is, unless I had a negative and I'm flipped upside down, which I don't, I just alternate between 0, maximum, 0, minimum, 0. And once I have that pattern established, I repeat it on the other side. And there we go. And let's see how we did according to Desmos. You guys, you still can absolutely use Desmos to check your math. But I do recommend at this point we try some things that aren't necessarily focused on using Desmos because it will help you for the college classes. Okay, I'm going to change my my window here to match what I graphed. And this time, instead of stepping by pi over 2, it makes more sense, it looks like, to step by pi over 6. Okay, so double check this graph against mine. Okay, let's try another one. I'm just going to go ahead and delete everything this time. I think I heard one of you say you want to do a cosine function, and that makes sense to me. Let's do, I keep doing that. Let's do y equals, let's give it a amplitude and a new period. Let's give it 4 cosine of 2 pi x. Let's be adventurous. Okay, so I can see here that my amplitude is 4. As I teach you, by the way, all of these tricks, you're going to have quizzes and your questions on your midterm are going to be related to asking you what are the amplitude, new period, horizontal shift, and vertical shift. So I do want you to get used to identifying those first, and that's part of why this graphing by hand is going to be valuable, is it makes you identify these right up front. I know that I'm going to have a new period. So I'm just going to set this up. And I know that my normal period for a cosine, just like with sine, was 2 pi. Remember, tangent was different, but sine and cosine were both 2 pi for your normal period. I set it equal to what I have inside the parentheses, just the bx, and in this case your b is 2 pi. And I solve for x. and I get 1 is equal to x. So that means my period here is equal to 1. Set up your xy axis. I'm going to establish 1. I'm going to divide it into 4 pieces. I like to start in the middle. Half of 1 is, of course, 1/2. Half of 1/2 is 1/4. Kind of putting those way down there, I don't know why. Halfway between half and 1/2 is, oh, I'm trying to put pies in there, look at me, is 3/4. And then I repeat this on the other side. Okay, my amplitude here was 4. So if I were to put these together, I have a cosine this time. Cosine starts at the maximum point. So if you remember using the unit circle, again, 0 was along the positive x-axis. That point was at the point 1, 0, and we talked about how x was equal to the cosine. So therefore the x value of 1 was equal to the cosine. And in this case, of course, I'm taking this 1 and multiplying it by this 4. So the cosine, this part right here, when I plug in 0, this cosine becomes 1. I multiply it by 4, and that's why I'm getting this 4 here. Once you have that one target point, then graphing trig is just, again, as easy as alternating between minimums, maximums, and zeros. So here, 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 here. And once you have your pattern, repeat it on the other side. How are we doing so far? If you have confusions, please contact me. Either come to my office hours or send me an email. Okay, so when I changed my window this time, I want my y's to go, I like, again, for them to go a little bit past this. So I'm going to send it to negative 4.5 and 4.5. And then here I went from negative 1 to 1. So I'm going to mimic that here on Desmos. And I wanted to step it by 1/4. Oh, I see what I did. I forgot to put this 2 pi in. You guys probably caught that. Nobody said anything. Okay, here we go. Okay, so if I now compare that graph to what I had over here, at negative 1, I had my maximum of 4, just like I did here. At negative 3/4, I have my 0, and so on and so forth. So, what I want you to practice with, and I'll do another example for you, but what I want you to practice with is graphing these functions with a period change. I'll get into the shifts, especially the horizontal shift, in your next lesson, but I am a little bit worried about overwhelming you with too many things in one day without you practicing in between. What I want you to practice with is some of these graphs by hand. I'll give you just a handful of questions, and I want to see your homemade graph. And one of the things you will need to put with your homemade graph is the amplitude and period change for your graph. I'll keep all of the shifts out of it. but I do need that much to see that you have that. Okay. Oh, that's not what I meant to do. Let's try that again. There we go. Alright, you guys are so patient. You're wonderful. Okay, so let's do something outrageous. Let's do something like, I'm going to use a cosine again because I did 2 examples with sine, so it makes sense to use cosine. Let's use negative 50 cosine of x divided by 25. Okay, so my amplitude here is going to be 50. I'm going to go ahead and call it negative 50. Realistically, amplitude, it is okay just to call it 50, but I'm going to remind myself of that negative. To remind myself, I'm going to have to flip my graph upside down. I know I'm going to have a new period. And so over here I solve for it. I'm going to take x divided by 25 and set it equal to the normal period. So remember, this right here is bx. Now it turns out that my bx is 1/25 times x. It is okay to write that as x over 25. That is how fractions work. This right here was my normal period of cosine. Okay, so once I have this, I'm going to multiply both sides by 25. And I get x equals 50 pi as my new period. So 50 pi here. Over here, negative 50 pi. And I know I'm going to go up to 50 at my maximum, down to negative 50. And then on my x-axis, I know that I'm going to want it to divide it evenly into 4 pieces. So let's see, half of 50 is 25. And then half of 25 is 12.5. Let's see, so that would be 37.5 pi. Do the same thing over here, but they're negative. Now, if you're confused on any of these problems, I am going to say don't just sit and stare at the screen. You gotta jump in and give it a try. One of the best things you can do is watch the video I'm making, pause it before you see me actually start the problem, and try it on your own, and then see if we get the same answer. Go through the problem, race me, which will be easy to do because you're going to have me on pause, and see if we get the same answer. Okay, so my cosines, remember, cosine was my x, and at this point my x is 1. Normally I would start at the maximum, but because I have a negative, I did flip myself upside down. So I have instead, I'm going to start at my minimum because my negative flipped me. And once you have that point, all you have to do is alternate. That was a silly place to put that. Here. I'm going to put you over there. Okay. Here. Here, here, and once you have your pattern, use it to find the pattern on this side. And voila, so pretty. Okay, so I come over here, I'm going to change my equation. I had negative 50 cosine of x divided by 25. And I need to change my window so that, because notice here, my graph, there's nothing there. And it's just because right now it's zoomed in to like right here. I need to change my windows so that it matches my whole graph. So I come over here. I went from negative 50 pi up to 50 pi. And I stepped by 12.5 pi. My y's, I took those from negative 50 to 50. And again, I like to go a little bit beyond, so on this one I'm going to say 55. Negative 55 to 55. Okay, and let's see how I did. They changed what they called this, which it makes sense. They defined it in terms of pi over halves instead of having a decimal in there. That actually, again, you use more fractions than you use decimals in higher math. But I see that my minimum started at negative 50. And then I had my 0. And then at negative 25 pi, I had my maximum, 0, my minimum. And I see that this pattern then repeated itself. So what I'm going to do is I'm going to give you just a few problems. I'm going to write them up on Canvas, and I want you to graph them by hand. You are more than welcome to double check your work in Desmos, but I'm going to give you a couple where I can kind of see if you just copied it off Desmos or if you tried the methods that I did for you in this video. We're going to spend at least another week just graphing these things and just getting used to it. Mostly because there are some skills here that, like fractions and some of the graphing by hand, that I haven't had you practice, and I want you to just play with a little bit here. But then, of course, when it comes to your test time, the graphs themselves, I'm going to be okay with you depending on Desmos for that. Okay, so if you would like to see more examples on these problems, I am on Canvas on the Canvas conferences from 11 a.m. to 1 p.m. every school day. I will make up problems with you, and you can help make up problems too. And I can show you on the screen, and we can work one-on-one or in small groups just with whoever shows up on Canvas. If you cannot show up on Canvas conferences, please let me know sooner rather than later, and I'll do some special problems just for you to send out to you. But if you don't send me word that you need help, then it's going to be more difficult to do this. And also, please don't put off your homework till the last day, because it makes it easier if we can get it done a little bit earlier. Okay, so I hope you have a fantastic weekend. I will talk to you more next week, or if you want to reach out to me, then I will talk to you more before then too. I hope that you're staying safe, that you're washing your hands a lot, and if you need anything, just let me know, all right?